Hello and welcome to the walking talking topic on angles, question number 2 with me, Mr. Barton. Now let's take a look at this one. The diagram shows 3 parallel paths with a cycle track connecting them. Calculate the size of the angle marked Y. Okay, few steps needed here. My advice whenever I get an angles question is just to think what's going to help me get that angle. Well, I'll tell you straight away, if I can get this angle there, then I've got Y, because I've just got angles on a straight line. So that's looking good. But how am I going to get that angle there? Well, if you look up here, we've got parallel lines, and I think there we've got a lovely little Z shape, if I just mark it on with my dodgy pen. It's been letting me down a fair bit these last few questions. But there we get a nice little Z shape. So if I can get that angle there, then I've got that angle there. Well, how am I going to get that angle there? Well, to get it, I'm probably going to need this angle here, because then I would have angles on a straight line. Okay, so that gives us a starting point. Let's see if we can get it. Now, you can actually get this angle direct here, because you know that angle, and we've got a pair of parallel lines there. Now, there's a bit of debate going around about what you actually call this angle relationship between those two. Some people like to go for allied or co-interior angles, or complementary or supplementary angles. I'm a fan of co-interior, but again, whatever floats your boat on that one. But the bottom line is that angle there and that angle there are going to add up to 180 degrees. So that angle there, I reckon, is 35 degrees. There is another way of getting that, by the way. Some people like to work out this angle there is 35 degrees, because angles on a straight line add up to 180, and then you've got your bit of a Z shape going on there, your alternate angles. Anyway, that's 35 and that's 80, so what's this missing one here? So you've got 35 and you've got an 80. Well, if you bang those two together, I think you get in 105 degrees, and angles on a straight line have got to add up to 180 degrees, so I think that that is going to be equal to 75 degrees, that particular one there. Well, if that's 75 degrees, now we're flying, because we said before that that angle and that angle there must be the same because of alternate angles, so that there is going to be 75 degrees as well. And finally, we've now got angles on a straight line equal 180. So we've got 180 degrees take off me 75 degrees, which is going to give me 105 degrees, which is going to be the size of angle Y. Quite nice, that one. I enjoyed that question. What about part B? Calculate the size of each of the angles in the triangle. Now this time we've got flipping X's bombing around, but that's okay, because we know something about angles in a triangle. They add up to 180. And we also know those 3 angles. That one's X, he's 3X, and he's 5X. So when we add those together, we must get 180. Well, that gives us a lovely little equation to solve now. We've got an X and 3X, that's 4X's, plus another 5X's, that's 9X's. So 9X's must be equal to 180. So what does that make 1X equal to? Well, if we divide both sides by 9, I think we get 20. And notice it says it hasn't said find X, it's calculate the size of each of the angles in the triangle. Well, that one's fine because he's 20 degrees. He's 3 lots of that, so he's got to be equal to 60 degrees. And he's 5 lots of that, so he's got to be equal to 100 degrees. And the nice bit about that is you can just check and they add up to 180, so you know you've definitely helped yourself to 3 very nice marks.